Okay, things are starting to get interesting. We have the ability to create different types of nodes. We have the ability to list them out. We can do all these cool things, but we don't yet have the ability to start creating hierarchies. So in this video, what we're going to do is create the parent command. And with the parent command, we can really start to control what our listing of nodes look like. So with the parent command, what we're looking for is a command that's going to consist of a total of 3 things. Let's go ahead and jump over to the whiteboard as a quick reminder of how this is going to work. Let's review. What we're looking for is, let's say we have a scene that has the following. So we have S1 and S2, just so that I don't have to do a lot of writing right now. And we want to create the following scenario. We want to, in fact, I'll draw it like this. We want to create, or not create, but establish a hierarchy where S1 is the parent of S2. So in order to do this, the command would need to look like this. Parent S2 to S1. So the key is child first to parent. Okay, so we're going to be dealing with arguments sub 0, that's going to be our command. Sub 1 is going to represent our child, and sub 2 is going to represent the parent. So that's the thing you need to keep in mind. There's one more thing that we need to really be careful with, and that is what happens if we already have a hierarchy in place and we try to take the parent of a child and make it the child of its child. Oh boy, that's kind of confusing sounding. Remember, this is a directed acyclic graph. We cannot have that kind of a scenario. Right, Logan?
Right, and it's an acyclic graph, so we cannot have any form of cycle, which in this case would be S2 being a child of S1 and S1 being the child of S2.
Yeah, my head's hurting.
So we simply can't do that.
Okay.
But with the current hierarchy we have in place now, what that would actually do is rip it out of the hierarchy and unlink it in a sense, where it doesn't ever link back to a root node.
Right.
So this would kind of orphan the entire branch if we allowed the scenario.
Exactly. So we obviously need to make sure when we create this command that we have 3 different arguments total in the array, 3 different elements, and then we need to make sure that both element 1 and element 2 exist. They're both transform nodes because you can't parent a shape node. Okay, so if they do indeed exist, then we can do the setup. All right, so Logan, with that, let's go and jump back over to Visual Studio.
All right, and let's make a new command. So once again, a command template where we're going to create the command parent. And we'll jump right into the coding where we do a check on arguments. So if arguments.length is equal to 3, then we have the correct number of arguments. Otherwise, we don't. So we'll have some form of error message saying that you must specify 2 nodes, which means we can set the output to the desired error text, where you must specify
2 nodes.
2 nodes.
Okay.
Otherwise, if we did indeed have 3 arguments, we can continue. The next thing we need to do is to get the text names and translate those into an actual child and parent node. So let's set up some references for those. They both need to be transform nodes. So I'll have child node, and it needs to be set to transform node.find, so we can look up based on the text. The text in this case for the child node is arguments sub 1, as seen on the whiteboard. And of course we need to cast this as transform node to make sure that we do indeed grab a transform node. Now parent is going to be the same thing, so I'm going to copy this line and paste it so that I can more quickly create the reference to the parent node. So parent node is going to be equal to transform.node find, except we need arguments sub 2.
That's
because
right.
Sub 2 is going to be the desired parent, the text name. Next
thing we need to do is go and set up another if scenario where we're going to check to make sure that we have found both the child node and the parent node. So because if either of the 2 weren't found, how can you parent one to the other?
One of the parameters is invalid. So we need to do a check and make sure that both child node is not equal to null, and parent node is not equal to null. And if that is indeed the case, we can continue. If either of them were null, then we need to set an error message. So output equal to
parenting failed.
Parenting failed.
Could not find the parent or child node.
Could not find the parent or child node.
All right, child. And perfect. All right, good deal. Okay, so one last check.
And this check, now we were talking about needing to make sure we don't run into a cyclic condition,
right.
Meaning we don't want to be able to take a child node, and then, take a parent node, set it as a child of one of its children.
That's right.
So that means we need to look at the child node, and then try to find that parent within its branch. So we need to check and say if child node dot find node, and then again this is the string, so this is going to be arguments.
Just put in. No, we got parent node already, so we just throw in find the parent node.
Oh yeah, that's right. We have already found it. So parent node name.
Name, yeah. So basically, what we're doing is we're saying take the child right now, and look through all of its children and see if the parent already exists in there.
So that is if the so we look for that parent name. We need to see if it exists. So we check and see if it is indeed null. If it's null, what that meant is that the child node did not contain the parent node. So then we can allow the parenting to continue. So we can say child node dot set parent to parent node. Otherwise, we have to do some error message.
Yeah, we'll just simply tell us something along the lines of cannot parent a node to one of its children.
Node to one of its children.
Perfect.
And I think that's all of the checks that we need to put in place.
Okay. We're going to need to make sure that we register the command.
All right. Let me make sure I've got no syntax errors, and that's good. And then back in the command manager under the editing command section, let me drop in a new command line where we link this over to a command parent under the text parent. All right. We should be able to try this out now.
Okay.
So let's see. Let's make a new sphere. So what do we have? Sphere and sphere 2. Let's parent sphere 2 to sphere. So parent sphere 2 sphere. List. And there we go.
Okay, now try to parent sphere to sphere 2. And sphere is currently the parent of sphere 2. So we would create a very interesting situation. Ooh, cannot parent a node to one of its children. Exactly as we were saying. All right, very cool. So let's see, what else can we do?
We could test some of the error scenarios. For example, parent by itself. Must specify 2 nodes.
Okay.
Parent with a node, so parent sphere. Still not 2 nodes. Parent sphere, sphere 2. And then we get into our last condition.
Okay. And make one just not exist. So parent sphere to cat. Okay, it failed because one of the nodes can't be found, basically. So let's go ahead and do an ls real quick.
Let me check the other way. Just so we have one other check. Make sure that all cases are caught, and they indeed are.
All right, let's go ahead and clear the screen real quick and do an ls. All right, let's see. Let's go ahead and parent sphere to spotlight.
Okay.
Because currently sphere is a child of group. This will make sphere a child of spotlight, and sphere 2 will continue as a child of sphere. So we should basically have this big stair step that runs all the way down. And there we go. Group 2 spotlight 2 sphere 2 sphere 2. Beautiful. And let's see. I think that's pretty much it. We now have parenting working perfectly. So let's go ahead and jump back over the code real quick. One last look at it. And really straightforward stuff. The bottom line was we needed to make sure that we had the right length, that we have the right number of elements in the array, which was the command, the child node, the parent node. Then we set up 2 reference variables, a child node and a parent node, and we did a search for arguments 1 and 2. We made sure that those two nodes existed as transform nodes. If they did, then we did the check. After we verified that they did indeed exist, then we made sure that the parent, we could not create this cyclic condition. Okay, after we took care of that check, then we just did the simple child node dot set parent. Here's my parent. It's really straightforward. And then, of course, we have just a series of simple outputs for if things didn't go well. Anything you want to add to this, Logan?
Nothing I think of.
All right. So with that, that is going to wrap up this video on the parent command. Thanks a lot.